In the last class, I was trying to charge you and you people got discharged totally. And we are continuing the charging process from my side and the discharging process from your side. Theoretically, it should be the other way. I should discharge and you should get charged. Is it happening? I don't think so. It must be like that. I should discharge and you should charge. But it's the reverse happening. I was charging and you are discharging. Last class we studied about charging and discharging of a cell. While discharging, terminal voltage is less than the EMF of the cell. While charging, terminal voltage is greater than the EMF of the cell. Open circuit, they are equal. Short circuit, terminal voltage equal to 0. And the maximum current that you can draw from a cell is E by R. And I also told how to identify whether a cell is charging or discharging. When a cell is discharging, current leaves positive terminal. When a cell is charging, current will enter positive terminal. That's the point. Okay. So this is the whole X-ray of cells charging and discharging. I think I had asked you one question like this in NCERT exercise 3.2. Hopefully, I hope you got the answer. Okay. Battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit, okay, no, we did this. We did this question. I'm sorry, we did this question and we wanted to do something else. This is the question that we wanted to. Okay, mistakes happen. A secondary cell after long use. I told you in the last class that the internal resistance of a cell depends on its age. As the cell ages, internal resistance increases. Old cell high resistance, new cell low resistance. This EMF is 1.9 volt but large internal resistance of 380 ohm. What is the maximum current that you can draw from the cell? Now, I maximum equal to EMF divided by internal, which is 1.9 volt divided by 380 ohm. Very good, 19 is multiple. So this gives you 1 by 2, this gives you 0.005 ampere. I think it's 5 milliampere, isn't it? It's 5 milliampere. But see, to start a car, you need a much higher, stronger current. With 5 milliampere your car, maybe your toy car will start, not your original car. So you can't use this cell for starting. So what to do? You have to buy a new cell. Your battery should be changed. And there was one more question. Okay, this one, 3.18. It says that a high tension supply. What is the meaning of high tension supply? High tension means high voltage. High tension means high voltage. 6 kilovolt must have a very large internal resistance. Why? See, suppose you have a very high voltage cell. See, I have a 6 kilovolt, which is 6000 volt cell. Okay, which is connected to a circuit, and say that this has got an internal resistance of say 10 ohm. What will happen if this gets accidentally short circuited? If it accidentally gets short circuited, then you can see this will short circuit and there will be a current, the short circuit current. I can call it as ISC. The short circuit current is nothing but the EM of 6000 volt divided by the internal resistance 10 ohm. This will give you 600 ampere of current flowing. And you studied in 10th standard that the heat generated is always I square into R into T. Heat generated is proportional to square of current. So if you square 600, you get a huge value. That means a lot of heat will be generated in the cell and the cell will there and then will die. It will burn out. It can explode. It can cause fire. So to prevent the short circuit and the damage, such a high voltage cell should have a high internal resistance. What will happen if it has got a little higher resistance like 100 ohm? Then this will be 100 and the current will be only 60 ampere and the heat generated will be decreased very much. Suppose it has got a high internal resistance of 1000 ohm, then the current will be only 6 ampere. So you can say a high tension battery should have a large internal resistance to decrease the short circuit current and damage of the cell. That's the point. Right. Okay. A low voltage supply from which one needs a high current must have a very low internal resistance. Why? Answer is there in the question. What is it? You have a low voltage supply voltage, but you need a high current. So we know current from a cell is given by EMF by R plus R. So tell me, if you want high current, what about the value of R? R must be very, very low. So answer is this thing. What is it? The current from a cell is given by E by R plus R, where R is internal and capital R is external. So to have a large current in the output, you need a very small resistance. So question and answer mixed together. It's like asking, what is the SI unit of power? It's just like asking, what is the SI unit of power? Or what is the SI unit of thermal current? The question contains the answer. Find out. Okay. Now more on. I said charging, you need an external charger. The terminal voltage is more, current will flow into the cell. Fine. Now this one. A storage battery of EMF 8 volt and internal resistance 0.5 ohm is being charged by a 120 volt DC supply using a series resistor 15.5 ohm. What is the terminal voltage of the battery during charging? What is the purpose of having a series resistor in the charging circuit? Let us draw a circuit diagram for this. This is based on charging. So you have a cell to be charged and the cell has an internal resistance. What is the EMF of the cell? The storage battery of EMF. This has got an EMF of 8 volt and the internal resistance is 0.5 ohm. This is charged by an external source of 120 volt DC. So that means that is like another source here. Okay, there is a source, positive here, negative here. This has got 120 volt. And the current will flow, this is 120, this is 8, so current will flow in this direction, the current will enter positive, so this is charging. This is charging and this one should be discharging. That is discharging. Okay, what will happen if you directly connect like this? You can see 120 and 8, there is a large difference of potential, 120 minus 8, 102 volt, 112 volt difference, and there is a very small resistance. So the current will become very, very high. The moment you connect it like this one, this cell will get damaged. So to prevent that excess current, what will you do? You will put a resistance in series here. You will put a resistance here. And the current will flow through this resistance. This is R. The value is given as 15.5. This is given as 15.5. What is the terminal voltage of the battery during charging? That's what asked is. What is the terminal voltage? Okay. How do we find the current in the circuit? How do we find the terminal voltage here? That's our task. So this is the whole setup of this question. Now you are giving 120 volt here, and what is the terminal voltage available? Where is the terminal? This is the terminal. This is the terminal of the cell, and you need to find out this voltage. Logic is very simple. Here you are giving 120 and there is a drop here. There is a drop in that resistance. So the terminal voltage, see this equation, terminal voltage is equal to 120 volt, 120 minus drop in 15.5. This is what we want. But if you want to find drop in a resistor, we need to calculate current. Okay, let us calculate the current first of all. Let me clear this picture and redraw that here. Okay, let us draw the circuit again because there is some technical problem with the shoot. So we will just draw the circuit again. The circuit has got a cell of 8 volt EMF with internal resistance 0.5, and there is a series resistance 15.5, and there is a 120 volt external source connected like this. A current will flow from this point and this will flow like this. There is a current, right? Now we can see the current is nothing but, normally we write E by R plus R, but there are two voltages here, that is 120, this 8. So what should you write? You should write 120 minus 8, because see, this is positive which will send the current in that direction, that is positive which will send current in this direction. They are opposing each other. So 120 minus 8 by the total resistance is 0.5 plus 15.5. So this gives you 112 divided by 16, that gives you 7 ampere. So the current in the circuit is 7 ampere. Okay, now the terminal voltage V of the cell. This is the cell and this is the terminal voltage V, and that should be equal to 120 minus drop in 15.5. So we'll write like 120 minus drop in 15.5. So you watch previous videos, make it strong, make these concepts clear. So that is 120 minus 7 into 7 into ampere current is into 7 into 15.5. That is 120 minus 7 into 15.5. 70 plus 35 plus 3.5, that should be 108.5. So this gives you 108.5, this gives you 11.5 volt. Okay, see, you are using 120 volt. By putting a 15.5 ohm resistor here, you can decrease that voltage to 11.5, which is more than the EMF of the cell, because we know in charging the terminal voltage will be greater than the EMF. You are giving 11.5 so that the cell will get 8, because what is the drop in the internal, drop in internal resistance is given by I into R, which is 7 into 0.5, which is 3.5 volt. Okay, so out of the 11.5 you are giving, 3.5 volt is dropped internally and 8 volt is available for charging your cell. That's it. Answer this question. In which of the above cells the potential difference between the terminals of the cell exceeds its EMF? You know that. I will not discuss this in the class. You should know correctly. Your answer must be correct. Most probably this question will come for next one of the next test. Okay, so prepare. Now we need to study something like there is a device called potentiometer which we'll be using in the laboratory lab experiment for your board practicals, and we have an experiment to find the internal resistance of a cell, and for that we need to use this equation. That's what we are going to derive. Relation between internal and external resistance of a cell. We know that for a discharging cell V equal to E minus IR. Okay. From this we can say IR equal to E minus V. Okay. From that I can say R equal to E minus V by I. Then we also know that terminal voltage has got a second equation which is V equal to I into capital R. So I is equal to V by R. Substituting you'll get E by V minus 1 into R. This is the derivation. This is what you have to write in the board examination also. Okay, let us do that again. Consider a cell, internal, EMF, external. This is now discharging current I. This resistance is R. Where to mark terminal voltage? Terminal voltage can be marked between these 2 points, or between these 2 points, or between these 2 points. So between A and B I get a voltage, between C and D also I get the same voltage. So that's what we normally mark. We mark like this one. It means any of these points. So the voltage between A and B is the terminal voltage. The voltage between C and D is also terminal voltage. So we have two different equations. We know for the cell that is always not E minus I into R. We studied, we practiced it. Okay. Now if you look here, Ohm's law, current is flowing, resistance is there, V equal to IR. So we got two equations, V equal to E minus IR, which I used here. V equal to E minus IR, and V is also equal to I into R. I used that here. Now simply rearrange it. How to rearrange it? See this. We have V equal to E minus IR. Therefore IR is equal to E minus V, or R equal to E minus V by I. But we have V is also equal to I into R. So I need to eliminate this I. So I'll write I equal to V by R, and I'll use that here. So we'll get R is equal to E minus V divided by V divided by R, which will give me R is equal to E minus V by V whole multiplied by R, or R is equal to E by V minus 1 into R. This is the relation that you need for a device called potentiometer experiment, which we will study at the end of this lesson. Okay, so this is very important derivation, very important relation too. Okay. Now again questions about internal resistance. See, the diagram shows a circuit used in an experiment to determine EMF and internal resistance of a cell. A graph was plotted of the potential difference V between the terminals of the cell against the current I, which was varied by adjusting the rheostat. There is a rheostat. When you vary this current through the circuit will vary. The graph is shown on the right. X and Y are the intercepts of the graph. What is the internal resistance of the cell? This is the question. Read again. Pause video, read again. Pause video, read again. See the circuit. See the circuit. See, when you get a voltmeter and ammeter in every circuit, it makes it complicated. It looks complicated. It scares you. All the time, work out the circuit without using this voltmeter and ammeter. Remove them and operate the circuit so that it will become easy and simple. I'll tell you what. You just draw the cell. Do not use voltmeter there. Simply put the circuit like this. Now this is simple. There is a cell here which will have an EMF E. There will be a current flowing here in this direction, positive to negative. There is a resistance R. And the cell will have an internal resistance because it's given. It is to determine EMF and internal resistance. So there must be an internal resistance also. Then look at the graph. For understanding, I have done some graphics here. The internal resistance, the cell circuit, no ammeter, no voltmeter. Same thing, internal cell circuit like this, no voltmeter, ammeter. Now look at the graph, This graph has got current here and voltage on the y-axis. Voltage here, current here. See, when you look here, this axis, this point is current 0. Current 0. At that situation, the circuit will be like this. Its behavior will be like this. Even though there is ammeter and voltmeter, its behavior will be like this. And here you can see the current is maximum, and then the circuit will appear like this. We know current in a circuit is 0 when it is open circuited. So let us draw the circuit open circuited. The two ends are disconnected from the cell, from the resistor. Then you have the internal and the EMF here. Now these are the terminals. So this is your cell. This is a terminal. So the terminal voltage is what we call as V equal to Y. So the Y-intercept here is the terminal voltage in open circuit. Terminal voltage in open circuit. What is terminal voltage in open circuit? That is EMF. So I know that Y is equal to EMF. अरे बच्चों, समझ में आया? This is current 0 situation. Current 0 means open circuit. Open circuit means terminal voltage is equal to EMF, and this is the voltmeter is measuring terminal voltage, and the terminal voltage is EMF, and the terminal voltage is marked here as Y. Y is the EMF of the cell. Now, when current is maximum, the circuit should be a short circuited circuit. This is open circuit, but is that short circuit, that means there is no resistance here, direct connection. Then the current flowing, I is equal to E divided by R, where E is the EMF. And that current is given as X. So X is the short circuit current. And Y is the open circuit voltage. And we know X has a relation. What is X? X is equal to EMF by internal resistance. Now let us combine them. Y is equal to E, X is the short circuit current, which should be equal to E divided by R, and E is equal to Y, so that is nothing but Y by R. So what is the internal resistance R? X equal to Y by R is equal to Y by X. So this is the relation. You may not understand this in the first go. Watch the video, do this again and again till you understand. It's your duty to understand things. It's my duty to make you understand to my level best, but this will not always be successful. I can say no, some students understood, right? That's okay with me. But is it enough for you? You have to understand, because this can come in the next examination, this can come in the NEET examination, this can come in the JEE examination, or something based on this can come in when in the board examination. So it's your duty to study this. Okay. So watch the video again and again. How, what is this point? Why is this open circuit? Why is this short circuit, etc. Okay. A cell of EMF E has an internal resistance connected to rheostat. When the resistance R of the rheostat is changed, correct graph of potential difference across it is asked in CBSE board examination. Direct. You have a cell connected to a rheostat. You have a cell, this is a cell with internal resistance connected to an external resistance, a rheostat. This is E, this is R. This is the external R. External R is varied. External R is varied. What is the change in the voltage? So we know V equal to E minus IR. V equal to E minus IR. Now when you change this one, there is no capital R here. So we have to write this in terms of capital R. Okay. Now when you vary this resistance, I can say the resistance can vary from, you see the graph, the resistance can vary from 0 to infinity. 0 means short circuit, infinity means open circuit. 0 means short circuit, infinity means open circuit. Which of the graph will be the right answer? I give you all explanations. Which of the graph will be the correct graph? V equal to E minus IR cannot be used because here R is missing. So you have to write this in terms of R, capital R. Write V and R. Because I give you one more equation that we know I is equal to E divided by R plus R. So that you can substitute here. So you get V equal to E minus, instead of I you write E into R by R plus R. Work out, get the correct answer. Another one from your common DM, internal resistance of a cell is proportional to current drawn from the cell. Current drawn from the cell, then the best representation of terminal potential difference of cell with current drawn from the cell. This is pretty easy because the conditions are direct. We have a V equal to E minus IR, but it is given that internal resistance is proportional to current. So this will give you V equal to E minus I square. It's a VI graph. V equal to E minus I square. Choose which is the best graph. Okay. Please study the cells, charging, discharging, everything. We are going to another topic called series and parallel combination of resistors. These topics were studied in 10th standard. That's the reason that CBSE has decided to delete this from this year's portions. But of course, you have to study this for all entrance examinations. So that's why we are taking this. Fine. So the theory will be easy because you already studied this back. Series combination of resistors. NCERT statement, two resistors are said to be in series if only one of their end point is joined. There is a resistor, it has got two endpoints. This also has two endpoints, only one of them joined, then that's called as a series connection. So what happens in series connection? Current through the first one flow through the second one. Current through first one flows through the second one. Okay. So what happens when current flows through that one? I can say like this. Current will be same in series connection. What about voltage or potential difference? Voltage, see the potential difference here is calculated as I into R1. Potential difference here is calculated as I into R2. So if R1 and R2 are different, then the potential difference are different. If R1 and R2 are equal, then potential difference is same. So the voltage or potential difference may or may not be same. It can be different, or in other words I can say it can be different. It can be different. One more point. Now I say I have one resistor here connected to another resistor here connected to a third resistor. Many times students misunderstand this. How many of them are series connected? Answer, none of them are series connected, because one end is connected to other end, but there is one more resistor here. So this definition is not completely correct, what is given in NCERT. Two are like this series, but if there is a third connection, they are not series connection. So you should know two resistors are said to be in series, only one of their endpoints are connected without a third connection. This third connection should not be there. Keep that in mind. R1 and R2 not in series because R3. R2 and R3 not in series because of R1. R1 and R2 not in series because of R2. Suppose R2 is missing, R2 is absent, then definitely R1 and R3 are in series. In series connection, current is always same, but the voltage may or may not be same. It can be different. Equal resistor, same voltage. Now we have to find out the equation for equivalent resistance. Again, you have done this in the 10th standard. What we see is that we will consider R1, R2, R3 connected in series. Okay, when they are connected in series, you can see current flowing through each resistor is same. If the potential difference applied between the ends of the combination is V, then the potential difference across each resistor R1, R2, R3 is V1, V2 and V3. See this. This is what is meant. R1, R2, R3 are in series. Applied voltage is V. This is V1, V2 and V3. Now the relation is simple. This voltage should be equal to V1 plus V2 plus V3. The total voltage here should be equal to voltage V. Okay. The net potential difference V1 plus V2 plus V3. And what is V1? V1 is I into R1. V2 is I into R2. V3 is I into R3. That's what we have. V1, V2, V3. And substitute. So you'll get a okay, now what we get here is, see this. We know V1 equal to I into R1. We know V2 equal to I into R2 and we know V3 is equal to I into R3. Now, so what is the total voltage? That is nothing but sum of all these things where I is common, V1 I into R1 plus R2 plus R3. So V by I is given by R1 plus R2 plus R3. And what is V by I? V by I is the ratio of voltage of supplied and the current produced. V by I is the effective resistance. V by I is the effective resistance. In series connection we call it as RS, and that is given by R1 plus R2 plus R3. I don't think that you need to study the derivation in detail, so you can skip that one because it's not there in the board examination, but you just have to know the connections and the equivalent resistance. RS equal to R1 plus R2 plus R3. In series connection you can simply add them all. What about so many identical resistors connected in series? Identical resistors in series. Suppose I have 1, 2, 3, 4, 5, etc. up to n resistors. This is R, 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 R and up to R. Then you simply add them all. R plus R plus R plus R plus R plus R. How many R's? N R. So the series connection will give you Rs equal to N into R. Series connection always gives you more resistances. More resistance. Okay. That's about the series connection of identical n resistors. We have parallel connection to go, that we will take in the next class. Please study cell, very important. Derivation of this series connection, not to study result, only result. Okay then, bye bye, tata, see you.